Hello geometry students, here's your lesson for section 9.5, Effects of Changing Dimensions on Proportionality. Missy McCarthy, Okemos High School math instructor. In this lesson you'll learn to describe the effect of changing the dimensions on perimeter and area and apply those relationships to solve problems involving perimeter and area. So what we're really going to be taking a look at in this particular lesson is what happens, let's say, when you take this circle, like this little CD that's in this chart here, and you could actually measure the radius of this circle. Now what if we take that circle and we multiply its radius by a scale factor? So let's say we were to take the radius of this circle, I'm going to call that R. So R would be the radius of this little circle. And we take that R and we double it. So 2R, let's say, is the radius of this circle. Or we take it and we multiply it by, let's say, 6. So 6R would be the radius of this CD. So our question is, when you multiply a dimension by a scale factor, what happens to the perimeter and what happens to the radius? So how does the perimeter change? Or circumference in this case. And how does the area change? So those are the issues, those are the questions that we want to address, okay, in a nutshell. All right, so let's look at another example. Well, let's see if we can figure out what the effect is on the area if we change the height of this triangle. So let's find our original height. We know that the height of the triangle is area equals 1/2 base times height, which is 1/2 5 times 12, which is going to be 30 square inches. Now it says the height of the triangle is multiplied by 6. So our height is no longer 5. Our new height equals 5 times 6, which is 30 inches. So now let's see how our area changed if our height is multiplied by 6. So our new area is 1/2 base times height, which is 1/2 of 30 times 12, which is 15 times 12, which I believe is 180 square inches. Actually, it might be a little bit, yeah, it's 180 square inches. So it looks like when we change the height by a multiplier of 6, what did we change the area by? It looks like we changed the area by a multiple of 6 as well. So the area changed by a multiple of 6. So that keep in mind that's only when we changed one of the dimensions. That's only when we changed the height. We didn't change the base. Okay, so now we got to describe the effect of the change on the area of the given figure. So we have the base and the height of a rectangle are 4 feet and 5 feet, and both are doubled. So the key word here is that both are changed. Both are doubled. So it was originally 4 feet by 5 feet. So our old area is base times height, or length times width, which is 4 times 5, which ends up being 20 square feet. Now we're going to change them both. So our new dimensions are going to be 8 feet by we're doubling that by 10 feet. So if we want to find our new area now, our new area, base times height or length times width, is 8 by 10, which is 80 square feet. So how much did the overall area change by? This time, the area changed by a factor of 4. So the area changed by a factor of 4 because 4 times the original 20 equals our new area of 80. So when we only changed one dimension by a factor of 6, it changed the area by a factor of 6. But when we changed both dimensions by a factor of 2, it actually changed the area by a factor of 4. So let's see if we can draw some conclusions soon. Okay, so let's see what happens here if we take this triangle. Oh my goodness, I don't know my shapes. Take this circle J, and we're going to multiply the radius by a factor of 1/5 and see if we can determine what happens to the area. So the original area is pi times the radius squared. I'm going to leave my answer in terms of pi because I actually don't have a calculator right here. Times 10 squared, which is 100 pi square centimeters. So that's the original area. But our new radius is actually going to be 10 times 1/5, so our new radius is 2. So when we find our new area, it's pi times our new radius squared, which is 4 pi square centimeters. So what do we have to multiply our old area by to get to our new area? Well, our old area times some number would be equal to our new area. We would actually have to multiply that by 1/25, or some of you are saying divide by 25 perhaps. So our scale factor here now is 1/25. So notice the radius was changed by a factor of 1/5. The area was changed by a factor of 1/25. So if we look especially at our last two examples, we may be able to draw some conclusions about how changing the dimensions will change the proportionality. Okay, so if we're looking at, let's look at our last two examples. The dimensions were doubled or multiplied by a factor of 2. And the area was changed by a factor of 4. In our other example, the factor for the radius was 1/5, and the area was actually changed by a factor of 1/25. So if the dimensions is changed by a factor of a, it looks like the area is going to change by a factor of, what's the relationship? A squared. And that's what this says here. If you change the dimensions, plural, both dimensions of a figure by a factor of a, then the area would change by a factor of a squared. Now, we didn't explore this, but the other outcome is that the perimeter will just change by a factor of a. So this is for the dimensions. If you change the dimensions by a factor of a, then the area will change by a factor of a squared, and the perimeter will just change by a factor of a. So that's the conclusion we can draw. So now let's see if we can work backwards. Okay, so let's look at this example. It says a circle has a radius of 32 pi inches. I'm sorry, a circumference, I should read properly, of 32 pi inches. So that's the radius, and the circumference is 32 pi inches. Now it says if the area is multiplied by 4, then what happened to the radius? Well, we just said that there is a relationship that if the dimensions change by a factor of a, then the area changes by a factor of a squared. So here they're telling us that the area changed by a factor of 4. So a squared is 4. Then that means the dimension had to change by a factor of a, which would be 2. So the radius would change by a factor of 2. Now we can explore this and see exactly how that happens. If the original circle had a circumference of 2 pi inches, so the circumference is equal to, I'm sorry, not 2 pi, but 32 pi inches, then we could say that 2 pi r must be equal to 32 pi. Divide both sides by 2 pi and we would get r is equal to 16. So that was the original radius. Well, if that was the original radius, then the original area was pi times 16 squared. So the area was pi, I believe that is 256 pi square inches. And this I should put inches. Okay, so here is our original circumference, here is our original radius, here is our original area. And I said 256 and I wrote 25. 256 pi inches squared. So what we could do then, if we were to take this and we were to multiply it by 4, so let's say, what is 256 times 4? So that's 4, 2, 22, 2, 8. It's 1024. So our new area 2, would be 1024 pi square inches. And we could work our way backwards to see what the new radius would be. So this is quadrupling the area. So we would do pi r squared is equal to 1024 pi. Divide both sides by pi and take the square root. And we would end up with r is equal to, I believe we would end up with 32 inches. So it just confirms that the radius was doubled. It went from 16 to 32 when the area went from 256 pi to 1024 pi. So that's just a confirmation. Can you do it the shortcut way like I did it above? Absolutely. Okay, here's one last example, and we're going to do this one the shortcut way. An equilateral triangle has a perimeter of 21 meters. So if the perimeter is 21 meters, then that means this is 7 meters, 7 meters, and 7 meters. If the area is multiplied by 1/2, what happens to the side length? So again, the area represents it has been multiplied by a squared when the dimensions or the side lengths have been multiplied by a. So they're telling us the area has been multiplied by 1/2. So if the area if a squared is equal to 1/2 and we want to find the a value, we would have to take the square root of both sides. So we get a is equal to the square root of 1 over the square root of 2, which would be 1 over the square root of 2. But then we have to rationalize our denominator, and we have to multiply by root 2 over root 2. And it looks like the original dimensions were changed by a factor of root 2 over 2, and that's a. So that would be your answer. Okay, rewatch any parts of the video and make sure you understand what's happening with how the changing by a scale factor will affect the proportionality. If you're watching on YouTube, feel free to type in any questions or bring them to class tomorrow. And you know the drill. Talk to you soon.